what we're going to cover, if I can get that to advance, in this presentation is to give a little bit of credit where it's due for the existence of this tool. We'll talk about why we benchmark buildings and specifically lab buildings. We'll then give a quick introduction to what the lab benchmarking tool is, a description of how to use the tool, some of the basic features. We'll then talk a little bit beyond the basics, looking at the other modules that the tool has. There'll be a quick tour of the database that the lab benchmarking tool sits on top of, and then we'll talk about what's coming up in the near future in terms of incorporation of the tool into the new Labs to Zero program that I2SL is going to be releasing. So the LBT would not exist without the extensive work and volunteer time in many cases of a lot of individuals and groups. We are very grateful to both FEMP and Siemens for funding parts of the tool. The tool itself was designed and developed by all of these groups that are listed here, and a lot of these groups are still involved in maintaining and enhancing the tool as we go on. So thank you to everybody, and also everybody who submitted data to the tool in the past. It could not exist without your contributions either. So to take a step back and start at the beginning, why do we benchmark buildings? Well, there's lots of reasons why we do it, whether they're lab buildings or not. We do it to prioritize attention within our portfolios to see which buildings are more likely to need energy audits, for example. We do it for certification purposes, things like LEED O&M or Energy Star certification for most types of buildings. We do it to set targets for new designs like the AIA 2030 challenge. And we also just do it to start conversations about why our buildings consume the energy they do and why that's different from what other buildings consume. So lots of good reasons. We benchmark lab buildings for much the same reason as we benchmark any other kinds of buildings, but historically, it's been pretty difficult to do that. And there are some good reasons and some bad reasons for that. But fundamentally, it boils down to the fact that lab buildings are not a monolithic category. It would be unfair to compare a physics teaching lab to an intense chemistry research lab and say, well, they're both labs, so we can compare them on the same scale. And it's for that reason that lab buildings are not covered by most of the benchmarking programs out there. Labs are usually lumped into a sort of other category. There's no Energy Star score for labs, as I'm sure you all know. And so it's been kind of difficult to get good historical benchmarking on labs. Well, enter the laboratory benchmarking tool, which is the answer to that problem. What it is in a nutshell is an analytics tool built on a database of nearly 1,000 lab buildings. And the really key point here is that the lab benchmarking tool database contains not only energy usage data for all of those lab buildings, but also contains important lab building properties. Things like, is this a biology lab? Is it a federal lab? Is it a teaching lab? Those sorts of questions, so that you can use the filters that are part of the tool to slice and dice that data set of nearly 1,000 buildings to select true peer buildings to your own buildings, so you can make fair comparisons between lab buildings. Importantly, the tool is free to use. It always has been. You don't need to pay. There's no sort of paywall or subscription or anything like that. And that's partly a function of the fact that it was set up with government funding, for which we are certainly very grateful. So this is just a super quick overview of some of the charts and filters that are available in the tool, and we'll get into these in a little bit more detail in a few minutes. So you can see that we have various types of analysis charts. We've got scatter plots, histograms, sorted columns. We've got some summary statistics as well that'll tell you the mean and median energy use intensities of your peer buildings. We've also got a lot of filters that allow you to whittle down that database to get to your true peers. And then you can also compare buildings on a number of different metrics. So site and source EUI are two, but then we also offer comparisons based on greenhouse gas intensity and some subcategories of building use as well, like ventilation, energy use, plug loads, and quite a number of others. So we've got about 20 different metrics. Really important thing to note about the LBT is that it is a community tool. So the data that's in the database came from users like you, like others who have submitted their lab building data to the tool over the years. And what happens is that on a periodic basis, staff at LBNL go through, QC that data that's been added, anonymize the data, and then add it to the peer group database so that other people can search it and find buildings like their own. That anonymization part is important. All of the identifying information is stripped from the buildings before they're added to the peer group. So you don't need to worry about adding your building's data and people being able to find it. It's really fully anonymized. You can see that the number of buildings in the database has grown over time. We started collecting data way back in about 2002, and it's been mostly pretty linear. And now we're up there at, in fact, 990 buildings in our peer group right now. We're going to have a little party when we pass 1,000. That's going to happen probably within the next couple of months. So that's really exciting after 20 years of collecting data. So I wanted to just give a quick introduction to how to use some of the basic features of the tool. So when you first go to the site, log in, what are you going to see? How do you approach entering data? So the next few slides are going to deal with that. So entering your building's data. You do that via the Your Buildings tab here at the top of the tool. In order to see the Your Buildings tab, you have to have created an account and to be logged in. Otherwise, there'd be no way for us to save your data. So you need to create an account. It's a simple process. You would then click on the New Building button here. This example here has already got a bunch of buildings in it. You would start with a blank list there. And then you'll be presented with the Data Entry tab. And there's a number of tabs within that. And the thing you'll notice is that there are more than 100 data fields that you can enter for every building you enter into the tool. So that seems like kind of a lot, and it is a lot, and it's intentionally a lot because there's a lot of interesting things that we can learn about buildings if we ask those questions. There is a full list of all of the data fields on the Lab Benchmarking Tool website. I've put a link in the slides here, so you can go straight to that document that explains what each of those fields needs. It explains the units, the limits, the different options for those fields. So that's a really useful reference document if you're planning data entry into the Lab Benchmarking Tool. But a really important thing to note here is that only about a dozen of those 100+ fields are actually mandatory data entries. And those are some of the basic properties of the building, such as what it's called, where it is, what type of organization you're at, whether it's an R&D or a teaching lab, the approximate occupied hours per week, the breakdown of the building by lab space and non-lab space, the number of fume hoods, that's one that gets a few people, and then obviously the utility data use and the year that that data was for. So that's really all of the data that's actually mandatory before you can save the building and benchmark it in the tool. And if you have the right data, the process takes no more than 15 minutes per building. It can be exceptionally quick. The first tip here is that it's totally okay to use somewhat approximate numbers when you're using the Lab Benchmarking Tool. You know, if you're not sure whether your building has 60 or 63 fume hoods, it doesn't matter. The guru of benchmarking, Paul Matthew, loves to say that benchmarking is a soft focus activity, and it is. You don't need to have things to within 1% or to be fully precise to use the tool. And so, you know, if you're seeing all of these fields, it seems like a lot. Just know that if you just put in, I have 60 fume hoods and maybe you have 62, that's fine. That's the sort of level of precision that's required. So once you've entered your data, the next thing you're going to want to do is to use the benchmarking analysis tab to benchmark against other buildings. So the benchmarking analysis tab is the next one along on the tab bar at the top. And you use this tab to filter the database to select buildings that are like your lab building. Then you compare their energy intensity. So there's a process for doing this that was developed for LEED O&M way back in 2010. There's a link to that document here that's also on the site. That process is still, if you're not sure what to do, it's still a pretty good process to follow. It's also possible to just use engineering judgment to try to select peer buildings that are like yours. But as a first place to stop, this document's a good process to follow. The process tends to be kind of iterative because you really want to balance using enough filters that you're choosing buildings that are truly like yours, but not using so many filters that you cut down the peer group to being only like one or two other buildings for you to compare with. A rule of thumb would be with this size of database, if you're comparing to 15, 20 buildings or more, that's probably good, but you don't want to go any smaller than that. One other little tip here is that if you were looking at the data on the plots, the green dots are yours, the gray dots are other buildings or anonymous peer buildings. The plots are only going to show the most recent year of data for each building. So if you've entered multiple years of data and you're not seeing it on the plots, that's why. A quick example of how to benchmark a building using the benchmarking tool here would be, say you have a university campus and you have a biology and biochemistry building that has 45% of lab space by gross floor area, and it's in Boston, which happens to be in climate zone 5A. A pretty good set of filters to select to start would be select biology and biochemistry labs, select the climate zone, and then select a percent of lab area that spans yours, but also accommodates some range of lab area. And the lab area one's really important because that's one of the major drivers of energy consumption and energy intensity in lab buildings. We see pretty strong correlations between lab area percentage and EUI, which you'd expect, right? You'd expect that a building that has 20% lab area would probably be less energy intensive on average than a building that has 70% lab space by area. I also selected here the academic higher ed filter. And then you can see we've cut the peer group down from 990 to 60 buildings that meet those criteria. And we can look at some of the charts and see that this particular fictional building actually performs pretty well. It's 9th lowest in energy consumption out of those 60 buildings that are in its peer group. And this you can also see in the scatter plot of this actually isn't that building because the building's got 45% lab space by area. But you can see on the scatter plot, it also sits near to the bottom of the distribution. Before we move on to talking about some other parts of the tool, just some assorted usage tips that once you start using the tool could turn out to be helpful. One thing is that the lab benchmarking tool is for whole building energy analysis. It's not designed to be used for pieces of a building or lab suites or anything like that. It's to be used for whole buildings. Also, we would say probably if your building's got more than about 15% lab space by gross floor area, then the lab space is going to start driving the energy consumption of the building, and it's reasonable to use the lab benchmarking tool for benchmarking the building. You can view the data in the benchmarking analysis tab as a guest without making an account if you like. But as I mentioned, you do need to make an account so that you can save your data if you want to be entering your own building's data into the tool. We talked a little bit about entering just the basic data, the maybe 1 dozen fields that are actually mandatory and required. But certainly you can enter more of that data. And if you're interested in answering more of the questions, we applaud you and we appreciate that. What that does for you is it means that you can use more of the filters to select a more precise peer group for your building. But it's worth noting that not every building is going to have all of those fields. So once you start using some of the filters that are not mandatory, you'll see the size of the peer group drop quite quickly in many cases. It also enables you to get better insights from the actionable insights module that we'll talk about in just a little bit. And from our side, it really helps us to develop our energy and emissions programs for labs because we can get more information about the demographics of lab buildings, and we can use that data as we're setting up ranking programs and rating programs and certification programs for lab buildings. Another thing, if you're entering a lot of data, is don't go to lunch and leave it unsaved because there is a timeout and you will lose the data. We're probably going to change that and make it a longer timeout, but for right now, yeah, save before you go to lunch. If none of the above helps, then there's plenty of other places to go for help. One is that there's lots of mouse over text on the input fields in the tool. Any place you see an I, you can mouse over and get help text about what you should be entering in that field or how to use the filter. This is an example from occupancy hours where we're clarifying that we don't mean occasional overnight use in labs. We just mean normal business hours in the labs. There's also a pretty extensive FAQs page on the site. Took us a lot of time to write those, so please do check them out. We think we cover quite a lot of the typical questions that arise. If none of that works, or if you have suggestions, or if you find a bug, then email this address for personalized help, and somebody from ERG will help you with your inquiry. And then in future, I2SL is envisioning introducing an online user forum so that users of the tool can exchange tips and stories and be able to collaborate via that forum. So that's the basics. That's how do you enter your data and how do you do basic benchmarking of your building. Beyond that, we've done a lot with the LBT actually. So the LBT grew from the ashes of the old Labs 21 benchmarking tool, which was originally released in 2002. In 2019, we released the new LBT that you can use today that built on the database that the Labs 21 tool had. Every year since then, we've released a new feature or a new module, and we've gotten funding in order to do that. And then going into the future, we're going to be seeing a lot more enhancements associated with the Labs to Zero program. So right now, we're going to go through each of those modules super quickly, and I'll just explain what it is that they do and why you might want to use them. The first one is the Actionable Insights module, and this is something that was sponsored by Siemens that we launched not long after the tool itself launched in 2019. And what that module does is it takes non-energy data from the lab buildings that are entered, and it synthesizes that to make custom tips for energy efficiency measures for specific buildings. So for example, in this case, it's looking at this building and it's noticing that the building has a high density of fume hoods, and it's recommending that if you're looking for energy efficiency opportunities, it would be a good idea to look at the fume hoods and see whether you could implement some measures there. If on the other hand, the fume hood density had been lower, it would have advised you to look at overall room ventilation rates. Another thing we did in 2019 was to add a connection to Energy Star Portfolio Manager. So I think as federal organizations, most of you are entering into Energy Star Portfolio Manager, and we didn't want to make you enter your energy data twice. So you can connect your buildings in the LBT direct to your buildings in Portfolio Manager and do an automatic download of the energy data into the LBT. It goes that direction. It doesn't go the other way as of right now. You're still going to have to access the LBT to add all the other lab data that Energy Star doesn't ask for. But it certainly makes it easier than having to enter your energy data twice. You can set up a regular download so that it will upload your data, download your data to the LBT, and create a new year of data without you having to do anything. In 2020, we went beyond just energy benchmarking, and we started looking at benchmarking operational practices and policies. This is another tab on the tool. And the idea here was so that we could get a better idea of what constitutes industry standard practice for a number of these policies. Things like, do you have an energy manager at your building? How do you set lab ventilation rates? What is your minimum air change rate in your labs? Is it a policy? And so we ask about 20 questions about building operations and policies, and you can compare yours in the same way to your peers by using the filters, so that, you know, if, for example, you don't have an energy manager and you use the tool to find out that 90% of lab buildings like yours do have energy managers, you can go to leadership and say, look, I think everyone else is doing this. It might be worth considering. So that was launched a couple years ago. And then the last thing we did over the last couple of years was respond to a lot of inquiries we got from outside of the US, people in other countries wanting to use the tool, but being unable to use it in a logical way without workarounds because we didn't accommodate metric units and we didn't accommodate international addresses, but now we do. So we added that. We got support from FEMP and from Siemens to go metric. There's a toggle, you can switch between the two. And also to add greenhouse gas factors for other countries, flesh out the full set of climate zones and currencies and so on. So now anyone from anywhere in the world pretty much can use the lab benchmarking tool. Okay, so next, I'm going to give a quick tour of what's in the database, those 990 buildings that you can slice and dice. First of all, for the reasons I just mentioned, most of the buildings are in the US because we only recently moved to a fully internationalized model. So of the 990 buildings, most of them are concentrated on the coasts. There's a lot in California, there's a lot in Massachusetts, and in some other academic and sort of high-tech centers around the country. We've got some areas that have low density. We'd love to grab labs from those areas if possible. We have one lab in Alaska currently, and we have a couple in the peer group that are in Canada. If we split that up in terms of climate zone 5A, which includes Massachusetts and also Chicago, is way in the lead. 4A is next, which includes DC, New York City, and the Raleigh-Durham area too. We've got pretty good representation in 3A, 3C as well, and that's covering a lot of those California locations. If we start to look at it in terms of lab types, we've got a lot of biology, biochemistry, and chemistry labs. That amounts to more than half of the data set, a good chunk of physics and engineering, and then some other types of combinations. And if we look at lab use, R&D is most of the data set, although we do have 83 teaching labs in there and also some manufacturing facilities. And then if we look at the third way we classify labs, at organization type, you see that about half of the database is from academia. We've got about 160 federal government buildings in there, so that's a pretty decent sample size as well. And then we've got more than 100 bio or pharma buildings in there as well. And this is actually a brand new chart that came from a little audit we did recently of the data set, where we're attempting to go in and fill in some of the blanks that were remaining in the data set from the past. So we were able to reclassify quite a lot of buildings that were previously unclassified so that our unknown slice here became pretty small. Okay, so the last piece here is talking about what comes next. And what comes next is pretty exciting because, as you may have heard, I2SL is now working on a brand new decarbonization program for labs that will incorporate scores and certification. And that's all going to be built on the foundation of the lab benchmarking tool. So this is a graph that I took from some I2SL presentations. We got started with the development of this in 2022. And over the next few years, various components are going to be rolled out. I'm going to get a little more specific on the next slide. So specifically, we're going to see a greatly expanded actionable insights module that's going to incorporate a lot more savings estimates and case studies and a lot more useful information as a sort of automated initial energy audit of a facility. That's going to come out. We're also going to be developing energy and emission scores for lab buildings. As I mentioned, we don't have an Energy Star score for lab buildings, and so we're going to be working on developing one using the data from the Lab Benchmarking Tool database. Those scores are also going to be displayed on the Lab Benchmarking Tool site. And then as part of this program, we're also going to see a lot of other enhancements to the LBT. So we're going to get a lot of our wish list items are going to be granted, things like bulk data uploads, sharing buildings between different users, year-over-year comparisons for buildings. A lot of those things are likely to happen now that we have this larger program in the works. So it's a really exciting time. So to summarize here, hopefully I've convinced you that the LBT is a valuable tool. It's also a free tool, so I would encourage you all to try it out. It is really the only tool out there that lets you benchmark lab buildings in a meaningful way, which is to say using lab building properties to establish a peer group to get a true fair comparison of your buildings with other lab buildings that are like yours. It'll help you prioritize attention, get certifications, we hope, and also just start conversations about why your buildings consume the energy or other resources that they do. It also gives you a way to start to identify opportunities for performance improvement of your buildings. It will help I2SL and our community develop this new Labs to Zero program and develop our scores for that program that you're going to start to see coming out in the next year or so. And by entering your data in the LBT, it also helps you get ready for participation in the program when it gets released. And so at that point, I think I will end.